Example 2. Obtain the system model of the circuit shown below, given the input current I1 and the output current I5 across the inductor. We will start the solution. We will list the equations of the circuit. So we have the voltage, across resistor 1, which is equal to R1 current number 3, and we have for the capacitor we have C E dot of the capacitor is equal to I3, and we have E, the voltage at resistor 2, is equal to R2 I4, and we have the voltage at resistor 3, it is equal to R3 current 5, and we have the inductor di dt, it is equal to di5 dt, it is equal to the voltage across the inductor. And from loop 1 we have the voltages, so you can see that loop 1, so we will start with voltage at the resistor, so we have a plus ER1, and we have minus E, so we have minus ER1, here's R1, and we have a plus E of the capacitor, and we have a plus ER2 is equal to 0. Then we have the current. For the current, we have the current at 1 is equal to, so you can see that here's the current 1 is equal to I2 plus I3. And we have I2 is equal to I4 plus I5. And we have for loop 2, this is loop 2, we have minus ER2 plus ER3 plus EL is equal to 0. So we will apply Laplace transform for the equation listed here. So we have, here's ER1 is equal to R1 current 3, this is equation 1, and we have CS AC is equal to the current 2, this is equation 2,
will combine the equations here. So we have equation 1, we will substitute equation 1, 2, 3 into equation 6. Now we will get minus r I3 plus I2 CS plus R2 I4 is equal to 0. This is equation 10. Then we will substitute equation 3, 4, 5 into equation 9, and we will get, so R2 I4 is equal to R3 current 5 plus LS current 5. This is equation 11, and we will substitute equation 11 into equation 10. So we have minus R1 current to 3 plus I2 to CS plus R3 I5 plus LS I5 is equal to 0. This is equation 12. Then we will substitute equation 7 into equation 12. And the equation would be R1 minus R1 I1 plus or minus I2 is plus I2 to CS plus R3 current 5 plus LS I5 equal to 0. This is equation 13. And we have here, we reduce it, minus R1 current 1 plus R1 current 2 plus I2 CS plus R3 current 5 plus LS current 5 is equal to 0. Then we will substitute equation 8 into 13. So we have here's minus R1 current 1 plus R1 I4 plus I5 plus I4 plus I5 CS plus R3 I5 plus LS I5 is equal to 0. Then we will substitute in above in this equation. So we have equation 9. We will substitute equation 4 and 5 into equation 9. So we have here is ER2 is equal to ER3 plus E2. This is equation 9. So we have ER2 is equal to R3 current 5 plus LS current 5. Then we will substitute into, we have here is I4 so we will reduce this equation more, and we have here is minus, and we have here is minus R1 current 1 plus R1 current 5 plus I5 CS plus R3 I5 plus LS I5 plus I4 R1 plus 1 to CS is equal to 0. And we have here for the current 4, it is equal to ER2 to R2. And we have here is the equation of ER2, so we will substitute it here. Then this equation would be, after we simplify the equation, we will get the current 5 is equal to I5 to I1 is equal to I5 is equal to R1, R2, CS, and it is divided by CS, R1, R2, plus R2, R3, plus R1, R3, plus L S square C, R1 plus R2, plus R2 plus R3, plus LS. And this is multiplied by B current 1. We can find the state variable from the inductor and the capacitor. So we have here dI, we have here is dE for the capacitor by dt is equal to 1 over C I capacitor, and this is state variable 1. And for the inductor, we have here is d IL by dt is equal to 1 over L E L. This is state variable number 2. And we have here, we can follow away in order to make it easier. So by drawing the relationships in order to find. So we have here for DEC for the first state variable, dt is equal to 1 over C I for the capacitor, and the current for the capacitor, which is equal to current 2, which is equal to current 2 in the circuit. So you can see here, current for the capacitor is equal to I2, which is equal to I1 minus I3. We have here from I3 is equal to 1 to R1 EA, and we can put here is node A, and here is B. So here's the voltage at A. And we have the voltage at A, it is equal to EC plus EB. And from EB is equal to R1 current 4. So you can see that here, the voltage at B is current 4 multiplied by R1.